Who can give a nice interpretation of that? So that's not a very short phrase to interpret that well. So anyone want to give it a shot? What is f of pi over 2? What does it mean? Yes, ma'am.
It would be the sine of data when data is pi over 2, which will give you the vertical distance above the horizontal asymptote, which in this case is 1.
Okay, so it's this. She's saying that this is the vertical distance above the horizontal axis, measured in what unit? Radius length. If what? If we sweep an angle of pi over 2 radians counterclockwise from the 3 o'clock position. See how much is packed into that little notation right there? Just that little symbol? There's a lot of information packed in there. And what is the vertical distance and radius length for an angle of pi over 2? Yeah, we should have gotten 1. Why? Because that's the top of the circle, right? That's 1. Okay? How about f of pi over 3? Sure, go for it.
So it's the vertical distance above the horizontal diameter
In
radius length.
radius length.
When the angle swept is pi over 3.
Right.
From the 3 o'clock.
That's right, counterclockwise. And what is that vertical position?
It's radical 3 over 2.
That's radical 3 over 2. So here's where we got to remember those or have a way of accessing that information, some kind of method in your head so you can access that quickly. So those are ones you should know for your future math career. Okay, f of 7 pi over 6. You should have got negative 1/2. Did you get negative 1/2? 7 pi, f of 7 pi over 4. Minus? Radical 2 over 2. 2 pi over 3.
Also radical 3 over 2.
Also radical 3 over 2. Any questions? So these are all vertical positions above the horizontal diameter for the given angle. So input is?
Angle.
Angle, swept counterclockwise from 3 o'clock. Output is?
Vertical distance.
Vertical distance from the horizontal diameter. So what would be the meaning then of f inverse of x? Tell the person next to you. So what would the input and output be if we did the inverse function of f? Go, tell the person next to you.
Because your inverse is the input is your output of your normal function. So your input is the vertical distance above the horizontal. Right. And then your output is the angle.
So what would be the input now? Now we're inputting vertical distance and radius length, or y coordinate, right? Y coordinate. And the output would be? Angle, right? Angle. So it's flipped or reversed. Okay, so the inverse function for sine is called the arc sine. So you'll see it this way. Arc sine. Or this, you see it this way. They both mean the same thing. So this is called arc sine. This is called inverse sine. Again, the input is now. So now x in this inverse function, x represents
Angle.
X represents angle, right?
The vertical.
Vertical distance or y coordinate, and then the output of this function would be angle. Okay. So explain the meaning and find the value. Go. it show up now? Yeah, now it shows up. Good. A new bulb.
That's incorrect. It's not. Because you can't go above one. That's true. Yeah. I wouldn't have thought of that. I would have just been sitting there trying to figure it out next time.
Okay, so how would you interpret, somebody new, how would you interpret f inverse of -1? Or in other words, the arc sine of -1. Somebody new. Know that, you know. How was someone over here? We'll give it a shot. How would you interpret f inverse of -1? Okay.
That's the vertical distance that gives the output of an angle.
So is that thing, that whole expression there, is that thing an angle or a vertical distance? That whole thing?
That's given
That's the arc swept.
The output is an angle.
The output or that whole thing represents angle. It represents angle for a given vertical distance and radius lengths. Okay? So when the vertical distance is -1, what angle is that? Okay, 3 pi over 2. So the angle 3 pi over 2 gives a vertical distance of -1. Okay? What about at 1.3?
Invalid. You can't go above one.
If this is a vertical distance and radius lengths, then what happens here? It violates the rules of the function because what's the greatest vertical distance we could have? Right? So
Is that going to be
Can't
a choice
do
on
it.
the test?
what's that?
Can that be
Yeah,
a choice
that's
on
a
the test?
precise mathematical symbol there. Okay? Representation of does not exist. This does not exist because the function of the inverse sine is to take a vertical distance, and it can only take what range of values then? Yeah, so this arc sine then only accepts the lowest value is -1 and highest value 1. Okay? So how about 0?
Pi.
Pi.
2 pi.
What do you mean? There's more than one answer? 2 pi? 0? So something's going on here. What about this one? Square root of 3 over 2. These are the ones we did before, right? Didn't we did this? Pi over 3 gives a vertical distance of radical 3 over 2 and 2 pi over 3. So what do we have here is that when we input a vertical distance, how many angles do we get out?
More than one.
She asked, could there be infinitely many?
Probably.
Well, keep going. Your angles keep going in a circle. 2 pi can be 4 pi, 6 pi, 8 pi.
So here's input of y equals -1. How many angles will give so how many angles are associated with a vertical distance of -1?
In.
4? Do you see that I'm showing 5 there? How many are there? How many angles then give a vertical distance of -1? Infinitely many, right? Because you can just keep going. You can just keep going. I could keep showing you more of that curve, and there's all these places down here. Do you see?
I don't see anything.
Is that showing up?
Your graphs are
I'll try green.
grays. Your gray sheet's not
How about green?
I thought the red. That doesn't make any sense.
So our input is a vertical distance. Here's y equals -1. So what angles, this is showing, right, angle versus vertical distance. So what angles give a vertical distance of -1? There's lots every time we go around the circle. So every time you keep going around, you hit the bottom of the circle, you hit -1. All right, similarly, what about negative radical 3/2? Even, well, yeah, so like twice as many, kind of, right? Twice as many as infinity. So for any y coordinate that we choose as the input to this function, it's like there's a zillion angles that will give us that y coordinate. More than that. More than a zillion. Here's our radical 3/2. So you said for radical 3/2, you gave me two answers. Can you see on the graph which two answers you gave me? On the right. On the right graph, which two answers did you give me?
the intersection on the first.
So here's angle 0. So right here is pi/3, then 2pi/3. So right, going to the top of the circle, then on the way back down, we catch 2pi/3, and then this is back at center line at pi. Okay, so, but remember what the rule about a function is. Function is a deterministic relationship. Absolutely predictable, meaning when I put an input in, what needs to happen?
Get one output.
One output, right? So it's about predictability. Every time I put in radical 3/2, I need to get one value, not many. So right now, the way that it stands, this is not a function. In fact, it's grossly not a function, right? Because we're getting an infinite number of angles output for every input that we put in, right? So what we need is one continuous interval of the angle such that every value from -1 to 1 maps to exactly 1 theta. So what am I saying by that? What does that mean? So all of our possible inputs are -1 to 1. We need to get one angle out for each of those rather than an infinite number. Okay? So what can we do?
Set your boundaries for angle 0 to 2pi. I'm not going to use to get two outputs for some of those.
So if the input is y, okay? So here's all the possible inputs, right? -1 to 1. I want to get just one angle for each of those inputs y. So what I need is some interval of theta that gets me just one angle for each input. So he suggested from 0 to 2pi. Does it work? Let's try it. So what's your idea here? What's your idea for the interval that we need? Why not? So here he said 0 to 2pi. Does it work?
No.
Why not? Still getting 2. Another suggestion. So we need an interval of. So let's look at -2pi. So here's -2pi to 2pi. What interval of theta would give us 1 theta for every y input that we had? 0 to pi. What do you think about 0 to pi? So what part of the graph is that?
Pi/2 to 2pi or 3pi/2.
What's that?
Pi/2 to 3pi/2.
Okay, pi/2 to 3pi/2. So she's saying from here to here. Let's try that. Would that work? All right, wrong one. So for any input y, do I get exactly one angle? Yep, that works. Okay, but it's not the most convenient choice. So this works. This works for every, this is the right idea. For every input from -1 to 1, we get only one angle or one intersection. But it's not the most convenient choice. So let's see if we can come up with something better. So here's -pi to pi. How about here? So can we come up with something that's more, because pi/2 to 3pi/2, it's like, it's kind of far away from 0, and it's in -x territory. So it's not the kind of the ideal situation. And -pi/2 to pi/2. How about that?
Do you not want negative values of x?
What's that?
I said, do you not want us to have negative values of x?
It's okay. It's just there's different choices, and we want just kind of the most convenient and best choice. So this is centered on an angle of 0. So it's kind of more convenient. So what part of the circle are we looking at there? What's that? Third and first? Is that the third and first? Fourth and first, right? So really what we're saying is we're going to use that right there. All the y's from -1 to 1, tracking to all thetas from what? Least theta will be? -pi/2, and then to pi/2. Okay? So that's how we define. We have to cut this sine function away so that we only get one angle out for every y that we choose. Otherwise, if we don't restrict that range of outputs from -pi/2 to pi/2, then we're getting many, many angles for each input. But we need one output for each input. Does it make sense? Okay, so what I want you to do is using that now, do these again, okay? So do these again with this restriction that the angle has to be between -pi/2 and pi/2, okay? So now we truly have a function that gives one angle for each input y. So solve those again, and I'll give you some more new ones.
Still invalid. 0 and 0.
Again, no calculator. Okay, there you go. Okay, and if you feel good about those, so let's just go through them. So what will the one value be for the inverse sine of -1? Negative pi over 2, 1.3. Still doesn't exist. How about 0? 0. Radical 3 over 2. Pi over 3. Negative 1/2. So here, let me. Negative 1/2 will be right here. What angle would it be? Negative pi over 6. 1. That's an input of what would be pi over 2. And how about radical 2 over 2? Negative pi over 4. Okay, so now find these expressions. The arcsine of the sine of pi over 6. The arcsine of the sine of 3 pi over 4. The arcsine of the sine of 5 pi over 3. Okay? Go through the process. You got to go through the process and think about them. Talk them out.
Right? I think so. But because your arc sine can't, it can't be 5 pi over 3.
Okay, find someone to talk to. Talk through what you're thinking. Everyone get a partner. Talk through what you're thinking on these problems. These aren't trivial. These aren't trivial questions. Okay? Find a partner. Talk them through.
Radical 2 over 2. Radical 2 over 2 would then give you 5 over 4. 5 pi over 3 gives you negative 5 radical 2 over 2. Radical 3 over 2. 3 over 2. That's negative pi over 3.
Always. That's how arcsine is defined. That's standard. That's how it's defined.
So this is looking at this arcsine to the sine pi over 6, saying like when we had functions, it was f of g of
Positive function. That's right. So where do you start? What do you start
So
with?
you start in the parentheses sine.
Right. So what's sine of pi over 6?
So 1/2 of the arcsine is
Not 1/2 of the arcsine.
no arcsine
Of 1/2 is what? Pi over 6. What's the next one?
3 pi over 4 is negative. No, it's radical 2 over 2.
Radical 2 over 2. And this is the arcsine of radical 2 over 2. 5 over 4. Right?
And then 5 pi over 3 negative is radical 3 over 2. So in order to
Right?
get that, it's negative pi over 3.
Right. That's good. Yeah, you got it. Okay, so when you put pi over 6 into the sine, so right here, in fact, let's see. When you put pi over 6 into the sine, what output do you get? 1/2. That's right. Okay, so you get 1/2 for y. And so then what happens? Now we're taking the arc sine of 1/2. It's going to spit back that same angle because we're in this range here for 1/2. The range from negative pi over 2 to pi over 2, the angle is pi over 6. Okay, how about arc sine of 3 pi over 4? Is it 3 pi over 4? That's it? We're done? Yep, okay, cool. And then next one, arc sine of sine 5 pi over 3 is just 5 pi over 3, right? Cool, okay.
It's got to be within pi over 2 and negative pi over 2.
If we take an arc sine, the output's going to be what? It has to be between negative pi over 2 and pi over 2.
3 pi over 4 is not.
So that's why you have to think through these. You have to think through the process. Right? And the process isn't on your smartphone, and it's not on your laptop. Yeah, question?
So for those ones we weren't doing, was pi has to negative.
Always. Arc sine, always. The output's between negative pi over 2 to pi over 2. I was being sarcastic. So let's talk through it. What's the sine of 3 pi over 4? I was seeing how many people were not really trying, and it was about half. So sine of 3 pi over 4, what does that mean? So it's good that you were, no, if you were uncomfortable with, that's very good. Okay, sine of 3 pi over 4, what is it? So that angle is here. And so we want the y-coordinate now, which is radical 2 over 2. Let me move it up. This is about radical 2 over 2 for a y input into arc sine now. What's the output of arc sine when the input is radical 2 over 2? Pi over 4. It's got to be that angle that has the same y-coordinate, but between negative pi over 2 and pi over 2. Same thing again. Sine of 5 pi over 3. That angle is about right here. So here, starting here, there's 5 pi over 3. And so the y-coordinate, the output is? Negative radical 3 over 2. So now that's the input into arc sine. Pi over 3? Almost. Negative pi over 3, right? So this is the way that arc sine, the convention from arc sine. So pi over 2 to 3 pi over 2 would work. That was a good suggestion. But just in the math world, this is what we decided on because it has nice symmetry around the origin, right? So we do from negative pi over 2 to pi over 2. That's always going to be the output of the arc sine. Will be an angle between negative pi over 2 and pi over 2. Okay, so now I want you to go to page 281. We're going to jump back. I want you to do number 6, A and B. Number 6, A and B. We've got to think through these, okay? Think through what's going on here.
This is kind of like those on our test. 0
Was there a skier on the test?
Yeah. He's going in a circle too.
Those skiers. It's going in circles.
How many kilometers did this skier travel? So, point radius.
Because it's on this side of the graph, which means it's within ours too. So it's going to be the same with the sine. Your input is oh yeah, plus minus all. So you go that many radians. Wait, divide that by what? And multiply by 2.5.
Is this the one you're doing?
Yeah.
How'd it go?
And why?
How's that going?
Why did we use sine? Because you want to find
What are you trying to find?
radius length, but you don't have that. But you have the arc sine. Well, because you
Arc
don't have
length. What? So, if you want to get arc length, what do you need to get that arc length?
the radius length, but we don't have
You need the
we don't
angle.
have
That's
angle
right.
or the arc. Yeah. Okay.
So to get that distance, you're going to need what?
Skier traveled on a circular trail, starting at a point, blah blah blah, and ended the position.
So what are you going to need to get arc length?
You need theta.
What's that? We got the radius, it's 2.5. What else are we going to need to get that arc length? Theta. Theta, because S is R times theta, right? Did you solve it?
I believe it's 3.4 kilometers. Because no,
You said 2.2.
oh, I added multiplied. Sorry, wrong. Yeah, it's 2.2. So it's not 1 line.
Okay, so you have to use a lot of what we learned before and now the new stuff. So we got to put it all together. So if you're stuck, ask someone around me or ask me as I come around.
I didn't know. And so for B, well, your vertical distance is the same.
So what? Word of the whiteboard. Expert. So, okay, so what would you just say?
I'm lost in that one.
Yeah, we didn't learn about percent, so let's stick with our.
So just this divided by
It's the same point, it's just the opposite side. How many kilometers? How do you track it?
Perfect, yeah. And then from that, you can get the angle out.
you said it was
Percent.
0.88 roughly radians. Okay. So to get to the other side of the circle,
The answer is
pi.
Can you write the next question?
No, just because the other side of the circle. Travel. What if we no here? Let's say this is just like crazy. Probably doesn't even work. But pi is half a circle, so just subtract 0.88 from one side that will give you there, right? So you want to find pi, and then you want to subtract this. Yeah. 2.7. So like, what is the arc sine of pi?
That's inverse sine doesn't take kilometers. So it's kilometers, miles, millimeters, right? Radius length. You got the right idea. It's the radius length.
No, you're right. Take pi, subtract 0.88, right? Because your angle is 2.88, so you're going to subtract that.
And that would give you. For some reason, that does not work. Oh, we have to actually. And that would give you.
Yeah, this would give you, so you're
Trying to type radius now.
2.26.
So it would be 5. 0.65 kilometers. And if not, then I have to fill other dots about it to figure it out. This looks closer to the first one. Three is not. I don't know. 3 is here, 2 is here. 3 is like right here.
That's right. Then do part B. So if you
Yeah, I just.
So the key is that arcsine, its function, it doesn't know about kilometers, it doesn't know about miles or millimeters or centimeters. What does it take? It takes height in radius lengths, right? So we got to make sure that what we're putting into arcsine is radius lengths. That's what it operates on. If it's something else, it doesn't know any better, and it's going to think you're putting in radius lengths. Are we 0.77 radius lengths above the vertical right now? No. Okay, the coordinates are 2.3 and 0.77. Here's your clue, right here. Because your x-coordinate is 2.3, so these coordinates are in kilometers. So how do we get radius lengths from kilometers? Okay, so but arcsine is going to be y-coordinate, right?
Yeah.
So we need this distance right here in radius lengths.
0.7725 divided by 2.
That's right. We're going to take how many kilometers it is divided by how many radius lengths in 1 kilometer. What fraction of a radius do we have? What is that value? What is it?
0.309.
Okay, that seems better. So now, see, 0.7725, arcsine's going to think you're talking about up here. 0.77 of the way up to 1. But really, we're just 0.3 of the way up. So the arcsine of 0.309, you can use your calculator, is? One more time? What's the 0.314? What does that number mean? What does that number mean? You should know what that number means, what it represents. Angle? Arc length? Arc length. Arc length? It's both. It's both angle and arc length, as long as you know what the arc length is measured in. Radius lengths, right? So it's either it's 0.314 radius lengths of arc length, which is the same as 0.314 radians. It's both. But it's not kilometers, that's the thing. It's radius lengths. So to get the distance in kilometers, if we've got 0.314 radius lengths there, how do you get the distance in kilometers? Yeah, so we want that. That's the fraction of a radius, so we take 2.5 times that. 0.785 kilometers. Awesome. Okay, how about part B? So part B is a little... So in part B, we get the same distance above the horizontal, see? Which was what, 0.309? And when we put that in to arcsine, we get the same thing out. What was our number of radius lengths? 0.314? Did the skier ski 0.314 radius lengths? No. How can we get the number of radius lengths the skier actually skied now if this is this over here is the 0.314 right there. We want to get all of this. How can we get that number of radius lengths? That is what I'm drawing in red, using the number of radius lengths that we got from the arcsine. He wants to subtract it from pi. That's it. That's it. So we're going to go pi minus, minus 0.314 is the whole half circle minus this little bit right here, which is also 0.314, gives us how many radius lengths? 2.82 radius lengths. That feels right. It's almost a pi, right? 2.82 to get the number of kilometers. Each radius length is 2.5 kilometers. So when you use arcsine, especially on the calculator, you have to know what you're doing, right? You have to know what number you're giving it, what number it's giving you. It will always give you an angle between negative pi over 2 and pi over 2. You have to be the manager who's smart and knows how to adjust that number to get what you want. So this arcsine thing is a tricky thing. It's not just something you push a button and it gives you the answer, right? So you have to have some savvy and know what's going on. Okay, we will have one kind of half assignment. My last day is Monday, so we'll have a half assignment due on Monday. What's that? Hopefully this afternoon. Well, I'll get the results back this afternoon, and then I can, in the next day, I can.
And will there be a web work for the final?
No, but all those web works will be open.